Hello everyone, welcome back to the course again. So I'm recording this lecture for the topic on training and testing dataset. So we'll be discussing about it, what training and testing data are, how to use it, why we are using it, how it helps to improve your forecasting accuracy. So let's get started. So whenever you are building a model or training a model with a particular data set, so for this example, what we had for exponential smoothing, if you recollect the dataset, so I have taken the similar one. Now suppose you have this historical data till July, you have it, uh, and you train your model based upon this historical data set. And once you have the model built, you don't want to directly uh, test the model into the real scenario. Hmm. Suppose assuming today is July, this month is currently July, and you want to forecast it for August, right? And you don't want to build a model with using the historical data points from Jan to July and directly test it into August, upcoming month. Why you don't want to do this? Simple reason. If you don't know how much reliable the forecast is, the forecast accuracy would be, and if you directly use it, then you may face real world problems like there may be order failures, or there may be excessive inventory. So first you want to test the forecast before using it directly. So how do we do it? So suppose we have a historical data set, and let's consider you have this much. So we split that data into two parts: training set and test set. So in this case, suppose I have this much of historical data, so I will use some part of it to train the model. Let us assume this much I'll use for training the data, and this I'll use to test the data, test the model, test the model how the model is performing for these many points. We'll use this much to train and this to test the data. Let me just differentiate them with two different colors so that it's easy to understand for you. Okay, so once we have built the model using this training data, we would like to test it for the this test set. Now you may ask that how what should be the split of training and test data, whether it should be 50%, 50%, 10% of train data, 10% of test data. So what is general practice in data sciences? It's 80-20%. So for training data, let me write it somewhere above. So for training and testing, the ratio is of 80-20, 80% to 80% to 20%, or this may sometimes vary from 75% to 25%, or 70% to 30%. This is the broad range of taking the various splits for training and testing data, right? So that's the first practice, that's the first way, thumb rule, to split train and test data. Second thing what you also need to keep in mind, that first, if you go into in the sequence, the recent period has to be the test data, recent historical periods, and the older ones, hmm, which are not the recent, should be used to train the data. So you definitely would like to test the model for the recent periods, how it's performing for the recent periods, so that it's easy to judge for you how it would be performing for the recent forecast. So that's the two thing. So let me show you how I'll go about it. So since this is the training data, yeah, so let us take this. I'll perform the whole exponential smoothing method for this training data. So I'll take this thing, absolute error. I have this error, then I calculate absolute error, then there is this percentage, and here I have MAPE calculated for the training data. So let me just take it for the training data. Yeah, so this is the mean absolute percentage error. We are yet to calculate the alpha. Alpha is the optimized value of the alpha, since it's an exponential smoothing method. So here I have applied the formula as well. So it's alpha times of actual demand plus 1 minus alpha of the forecast. If you are not able to recollect, this we discussed in our exponential smoothing lesson. You can always go back to it and revise. So we have, now we'll be optimizing the alpha. So since it's taken 0 for now, uh, that's why the value everywhere is coming 42, which is the recent actual demand. But yeah, we'll optimize it, optimize the formula for it. So let us get started. So let's take the data, and I want to do data analysis. Take the solver to optimize. Okay, so here we have the D30. It's already taken D30. D30. Okay, yeah, D30 is the mean absolute percentage training error that we want to minimize. So minimum has been taken. What can we change? E3 is the variable part, and E3 has to be less than 1 and greater than 0. Perfect. So based on this, now the alpha will be calculated. So let's hit solve for this. We'll wait for some time, and it would give a output accordingly. So this may take some time. That's why that's the particular drawback of using Excel. It's slow term sometimes for the iterations, and that's why people prefer to do with the uh, Python. So meanwhile, till the time Excel is calculating, so we need to first calculate the accuracy for the training data. Once the accuracy is good for the training data, whatever accuracy would come here. So let me hit OK. Now you see the optimized alpha which has come, which is 0.3, and the accuracy is 40%. Now if you ask me in real time scenario, and I'm working on a model which is just giving me 40% for the training data, I would reject it here and here itself. But let us assume that it has cleared. Now we have got good training accuracy, which is around 80%. Then we go to second step. And check the accuracy for the testing set also. So now the model is built. We have uh, we have only used these data sets for optimizing the alpha. Now what now the for testing set also the forecast is calculated. So let me just pull all the data points. So okay, now let us just see how much is the accuracy for the testing set. So here you see the accuracy for testing set is even worse. So why we want to test the model for the testing sets separately? Because we want to see how the model performs for the unseen data. Now these data points have been already used to train the model, so model has learned from those data points. So if when we try to calculate accuracy against them, or when we forecast against those data points from which the model has already learned, the forecast accuracy is going to be better. But when we try to test the model against the testing set, which is the unseen data, so model has not learned from these points. So the real capacity or real accuracy of the model will be tested against this unseen data, which is the testing set. Now here we see it's dropped by 18%. So suppose this is scenario one where uh, we have got training set as this and testing set as this. So our decision on selecting the model, whether we should select the model. The answer is straight away no. In real world scenario, uh, when we get 80%, when we have less accuracy in the training set, so we straight away reject the model there and there itself. We don't go to test it. Suppose there is scenario 2 where we have 80% of accuracy for for the training set, but we get low accuracy for the uh, testing set. So again we are supposed to reject it. Suppose we have a third model where uh, hypothetically we have low accuracy for the training set, and we suppose we are getting high accuracy for the testing set. In this case also we are supposed to reject the model. Why? Because the model which can't perform good for the historical data points which has been used to train it, it's very unpredictable, or it's very unlikely that it will perform good for the unseen data. So scenario 4, which is the real scenario, where we have kind of good accuracy here, good accuracy in the training stage and the testing stage as well. So when in both the cases the model is performing good, in that scenario we choose that model. So this is the right choice. Some more inputs here I have written. So model needs to be performed well on training data as well. So this accuracy has to be good, the training accuracy, which are the points which is used to train the data. Then again, the model needs to perform well then for the testing set. If the model is not performing well on these two data set, it will surely fail for the future prediction. So yeah, this was it. How you train your model by splitting the training set, splitting them into two parts, training set and the test set. And this is the ratio which we discussed. One more point which I like to add here. So sometimes data scientists, what they tend to do, they try to split them into different parts and try to see the model's accuracy for different splits as well. So that also is one way of doing it. And yeah, that's it what I had for this lesson. uh, Thank you, and hopefully you like this lesson.